We are going to learn about core concepts in vertigo. The balance system works by coordinated input from the vestibular labyrinth, the vision, the proprioceptions, which are integrated in the CNS in order to provide the gaze stabilization, orientation to our surrounding, locomotion, and the circadian rhythm and the autonomic functions are regulated in response to the vestibular inputs. Thus, the function of the vestibular system is gaze stabilization, the balance, locomotion, and the body position in the space, general orientation of the body with respect to the gravity, and readjustment of the autonomic functions after the body reorientations with the different vestibular inputs. The head movements can occur in the translation motion. If it is side to side, is known as the hip movement. If it is up and down, it is the bob movement. And if it is to and fro, it is the surge movement. Those are the translational motions, which are detected by the ventricle and the saccule. There is also tilt motions, which are detected by the semicircular canals. If it is no, then it is called yaw. Yaw. If it is yes movement, nodding of the head, is called pitch. And if it is torsional rotation, that is bending of the head to the right shoulder and to the left shoulder, then it's called the roll. Thus, we have yaw, pitch, roll, hip, bob, and surge, three translational and the three rotational movements. The vestibular end organs, that is the semicircular canals, ventricles, and the saccule, they sense this linear and the accelerations, and these motions are transduced into electrochemical signals in the CNS. CNS utilizes this information for stabilization of the gait during the head motions by means of vestibulo-ocular reflex and modulate the muscle tone by the vestibulospinal and vestibulocholic reflexes so that the appropriate posture is maintained during the head motions. So these are the semicircular canals, the three semicircular canals, the ventricle and the saccule, that is for the balance of the body. The ventricle and the saccule are known as the autolytic organs because of the otoliths they have. These otoliths, autoconia, are nothing but the calcium carbonate crystals which responds with the gravity. Whenever there is any translational motions, the body moves, but the autoconia remains because of its weight in a fixed position. As a result, the hair cells are bent by this weight of the autoconia. Thus, the autoconia are response to the gravitational force, and thus the movement are linear motions are detected. This is the orientation of saccule and the ventricle. There is a watershed area known as the striatum in both the saccule and the ventricle. In the saccule, the kinocilium is arranged away from the striatum, whereas in the ventricle, the kinociliums are towards the striatum. In the semicircular canal, in the ampullated end, there is a crista ampullaris, which has the cupula. These hair cells, the kinocilium and the stereocilia, are embedded in the cupula. When the head moves, for example, to the right, the fluid, the endolimb, moves towards the left, This causes bending of these hair cells. If the hair cells bend towards the kinocilium, they cause excitation moment, depolarization, and if the hair cells move towards the stereocilia, then it causes hypopolarization and inhibitory impulses. There are two types of hair cells, type 1 and type 2. Type 1 mainly has the afferent fibers, and the hair cells are linked by the tiplings. Thus, if as the hair cells bend towards the kinocilium, the tiplings open and the potassium goes inside. This results in release of the neurotransmitters and the chemical signals are generated. Type 2 mainly receives the efferent fibers and which modulate the functions of the type 1 hair cells. The direction of kinocilium in lateral semicircular canal is towards the utricle, and kinocilium is oriented away from the utricle in superior and the posterior canal, the two vertical canals. In the utricle, the kinocilium is towards the striatum, and in the saccule it is away from the striatum. Thus, because of this arrangement, ampulopetal in the lateral canal and utriculopetal in the utricle causes excitation and movement of the endolymph in an ampulofugal direction in the superior and the posterior canal, and the saccule causes excitation. Thus, excitation is caused by ampulopetal movement of fluid in the lateral canal and ampulofugal movement of the fluid in the posterior and the superior canal. From there, we come to the Ewell's law. Eye movement occur in the plane of the canal being stimulated and in the direction of the endolymphatic flow. Meaning to say, if you move the head in the horizontal direction like this, if you move towards the right, the endolymph will move towards the left. So, because the movement of the head is in the horizontal canal, the horizontal group of muscles are activated. Which are the horizontal group of muscles? The medial rectus and the lateral rectus are stimulated. So, if the head is bent towards the right, endolymph by virtue of inertia moves towards the left, and the lateral rectus of the left eye and the medial rectus of the right eye are stimulated, which causes movement of the eye towards the left in the direction of the endolymph. The second law states that the excitation of canal creates greater response than the inhibitory. It is something like this book, partially open. In the inhibitory direction, it just goes this much and it closes automatically. It becomes zero. It cannot go beyond that. But if you go in this direction, it can go all the way around like this. It's partially open normally. In this direction, little bit and it closes. It cannot go beyond that. But this side, it can go all the way towards the back. Thus, excitations have much more stronger response compared to the inhibition. In horizontal canal, ampulopetal causes greatest response, and in the posterior and the superior canal, ampulofugal causes the greatest response. If right canal is stimulated by turning the head towards the right, there is ampulopetal movement of fluid in the right, causing excitation response which is much more than the inhibitory response in the left horizontal canal, which has the inhibitory response. Because of the movement of the head in the horizontal direction, only horizontal canal is stimulated, and the movement of eye is in the horizontal plane. If the eye moves towards the right canal is excitatory and is stimulated much more than the left, which is also stimulated but is inhibitory in nature and is less compared to the right. However, the posterior and superior canal, uh, they are at the vertical angle, and ampulofugal causes excitation and a greater response compared to the ampulopetal, which is inhibitory and has less response. Now, let's go to this function of the ventricle. If you move head to the right or to the left, the body moves, the calcium carbonate crystal remains static. Thus, it will exert weight on the hair cells because the body has now moved, but the carbonates are static. And hair cells are bent by the weight of these calcium carbonate crystals. In the semicircular canal, we have seen that is the movement of the endolimb that causes the bending of the hair cells because it moves the cupula, which bends the hair cells. Here, it is the weight of the calcium carbonate crystals that is causing the bending of the cupula, bending of the hair cells. Similar to the semicircular canals, here also movement towards the kinocilium will cause excitatory response and movement towards the stereocilia will cause inhibitory response. Thus, movement of the head in the horizontal direction causes bending of the cilia in the ventricle. Now, let us tilt the head sideways like this. Tilting of the head sideways will also cause bending of the hair cells. Thus, ventricle doesn't have the capacity to recognize whether the head is turning to the left or bending to the left, because in both the cases, because of the weight, the hair cells are displaced in the same direction. That is why we need the input from the semicircular canal, because they are located at an angle, different angles. Any rotation of the head in an angle will cause either inhibitory or excitatory response, and this causes a body to know at what angle the body is rotating, or the angular acceleration is detected by the semicircular canals. The hair cells are constantly firing at around 90 spikes per second. However, when you when there is a head rotation or any translational movement, the firing rate increases. So if it's bent towards the kinocilium, it's excitatory because of depolarization, and if it is away from the kinocilium towards the stereocilia, it is inhibitory in nature. The semicircular canal work in pairs. The two lateral canals are parallel to each other. The right anterior and the left posterior. The right anterior and the left posterior are parallel to each other. The left anterior and the right posterior are parallel to each other. Thus, there is a superior semicircular canal in the sagittal plane, the posterior semicircular canal, and the lateral semicircular canal, and two horizontal canals are parallel to each other. The right anterior pairs with the left posterior and the left posterior pairs with the right anterior, and they work in a pairs. The excitatory in the right anterior is inhibitory in the left posterior, and excitatory in the left posterior is inhibitory in the right anterior. Excitatory in the left horizontal canal is inhibitory in the left horizontal canal, and excitatory in the right horizontal canal is inhibitory in the left horizontal canal. Thus, the six canals work in pairs. This is the schematic diagram to show how the left horizontal and the right horizontal are oriented. If it's excitatory in the right horizontal, it's inhibitory in the left horizontal. Similarly, The right anterior here is parallel to the left posterior, and excitatory in the right anterior will cause inhibitory in the left posterior canal, and excitatory in the left anterior canal is inhibitory in the right posterior canal. So, after the head movement, when this impulse finally relay in the vestibular nuclei, there are 4 vestibular nuclei: superior, inferior, medial, and the lateral. From there, the impulse goes to the extraocular eye muscle nucleus in order to coordinate the movement of the eye. So, if it is for the horizontal canal, it goes to the abducent nucleus of the opposite side, from where it goes to the lateral rectus of the same of that abducent nucleus side, and it crosses back to the right side again and goes and supplies to the medial rectus. Because the horizontal canal is stimulated, we know that the horizontal group of muscles will be excited by this impulse. If the vertical canal, the superior and the posterior canal, are excited, then rather than going to the abducent nucleus, it goes to the oculomotor of the trochlear nucleus, and then it supplies the superior oblique, superior rectus, inferior oblique, inferior rectus, and the corresponding eye movements are generated by the superior and the posterior semicircular canal. But for the horizontal canal, the medial and the lateral rectus are stimulated and causes the horizontal nystagmus or the horizontal eye movement. So, if you see here, if the lateral canal is stimulated, it goes to the vestibular nuclei. From the vestibular nuclei, it crosses the midline and goes to the abducent nucleus. This regulates the function of the eye movement. From here, it goes to the lateral rectus of this side, and it crosses back and goes to the middle rectus of the other side, because eye has to move in a conjugate movement. So, if the head turns towards the right, the fluid moves towards the left lateral rectus and the right medial rectus needs to be stimulated so that the eye will move towards the left in the direction of the endolimb. Thus, in order to fix a gaze, when our head bends towards the right, the eye has to bend towards the left in order to fix the gaze. Thus, movement of the head towards the right causes movement of the endolimb towards the left, and this causes movement of the eye towards the left by stimulation of the lateral rectus of the left and medial rectus of the right. This gives an conjugate eye movement by stimulation of the lateral canals. So, movement of the movement of the head towards the right side causes excitation of the right horizontal canal and inhibition of the left horizontal canal, and this results in stimulation of the left rectus and the right medial rectus, causing eye to move towards the left. The Florence law says that stimulation of each canal evokes a muscle contraction in the plane of the canal. That's what I just said. If the head movement is in the lateral plane, the lateral group of muscles are stimulated. That is, muscle contraction in the medial rectus and the lateral rectus occurs. If the vertical group of canals, the superior and the posterior canals, are stimulated, the vertical group of muscles, that is the superior rectus, superior oblique, inferior rectus, inferior oblique, are stimulated to provide the corresponding eye movements. Let's skip this for now. So these are the extraocular movement that brings about the eye vestibulo-ocular reflex in response to the head movement. The lateral rectus, they just move the eye left or right. The movement of the extraocular muscles is dependent on the position of the eye. So if the eye is abducted, the superior and the inferior rectus causes elevation and depression. Whereas if the eye is in adducted position, the superior and the inferior rectus cause intorsion and the extorsion. The inferior oblique causes extorsion and the superior oblique causes intorsion. However, in the adductor position, the inferior oblique causes elevation and superior oblique causes depression. The superior group of muscles, that is superior oblique and the superior rectus, causes intorsion, that is eye moves towards the nose, intorsion of the eyeball, and the inferior group of muscles, that is the inferior oblique and the inferior rectus, causes extorsion. There is law of reciprocal innervation, Sherrington's law of reciprocal innervation. It says excitatory signal to agonist and inhibitory signal to the antagonist group of muscle. So if the lateral rectus of the left eye is stimulated, it has to get an inhibitory response to the medial rectus of the left eye. Similarly, if there is excitation of the right medial rectus, it should get inhibition of the left medial lateral rectus. There is Hering's law of equal innervation. For the conjugate eye movement, yoke muscle should get equal innervation, meaning to say, if left lateral rectus is stimulated, the right medial rectus should be equally stimulated so that there is a conjugate eye movement in the left direction. So this is the final summary. Depending upon the anterior canal or the posterior canal, they go and stimulate the vestibular nuclei. From the vestibular nuclei, the fibers goes through the oculomotor, trochlear, or the abducens nuclei, depending upon whether it's the anterior canal, posterior canal, or the lateral canal. And then corresponding the superior oblique, the superior rectus, the inferior oblique, the inferior rectus, or the medial and the lateral rectus are stimulated depending upon the plane of the canal involved and the corresponding eye movement either in the lateral direction or in the vertical up or in the vertical down direction. If the lateral canals are involved, it pushes the eye away from the lateral canal. Movement of the head towards the right will cause movement of the foot towards the left, causing the movement of the eye towards the left. Similarly, movement of the head towards the left causes endolimb move towards the right, the eye move towards the right in order to fix the gaze. Posterior canal. Stimulation of the posterior canal causes movement of the eye downwards. This is the slow component of the nystagmus. It causes downward. But the fast component, actual nystagmus, is upbeating. The superior semicircular canal stimulation will cause eye to slowly drift upward. It pulls the eye upward. This is the slow component. Thus, superior canal stimulation will cause fast component will be downward. So, nystagmus is downward because the pull is upward. The slow component is upward. Nystagmus is downward. So, stimulation of lateral canal causes horizontal nystagmus. Stimulation of the posterior canal causes upward nystagmus, upbeating nystagmus. Stimulation of the anterior canal causes downbeating nystagmus. This is the simplified version of it. During the Dix-Hallpike procedure, stimulation of the right posterior canal will cause right upbeat nystagmus. Stimulation of the left posterior canal will cause left upbeat nystagmus, and it will be torsional. There is a torsional component. Okay, and the anterior canal stimulation will cause downbeat nystagmus. This is a better one. So, stimulation of the posterior canal will cause upbeating nystagmus with the torsional component. If the upper pole beats towards the right, right canal is involved. If the upper pole beats towards the left, left posterior canal is involved. Horizontal canal causes horizontal nystagmus. It can beat towards the ground or away from the ground, towards the ceiling. If it beats towards the ground, it's known as the geotropic nystagmus. If it beats towards the ceiling, it's known as the apogeotropic nystagmus. you will find that if the left canal is involved, the nystagmus and the symptoms will be more when that particular ear is towards the ground. And uh, in terms of apogeotropic nystagmus, it will less severe. Now let's go to the downbeating nystagmus. We know downbeating nystagmus is caused by the anterior canal or the superior canal. So superior canal causes downbeating torsional nystagmus. If it is prominently downbeating, then it is anterior canal is involved. However, some posterior canal, such as scupulolithiasis in the posterior canal, can cause downbeating nystagmus. But it is apogeotropic type of posterior canal nystagmus. Here the torsional component is more prominent. Upper bit pole bit to the right, then is left posterior here. Upper pole bit to the left is the right posterior. So it is opposite to what happens in the classical posterior canal BPPV. So the main function of the vestibular system is for the VOR reflex, vestibulo-ocular reflex. The cupula basically occludes the ampulla of the superior semicircular canal. The fluid can move only in one direction. It cannot, fluid cannot go beyond the cupula. Direction of the endolymph is in the direction of the movement of the eyeball, and there is canal VOR and the otolith associated, which is utricle and sacral associated VOR. So with this is the basic concept on the vestibular system. From here we can go on to the next topic.